Experiment 1, Part C1, the density of a solid. So we're going to determine the density of a piece of copper metal. To determine density, of course, you need two values, mass and volume. So our first step is going to be take a cylinder of copper metal and measure its mass. So I'll put it on my tiered balance, and I'll record the mass of that metal. Next, we're going to have to determine the volume. We're going to determine volume by seeing how much water the solid displaces. To find the volume of our metal cylinder, we will grab a graduated cylinder. This time I've got a 50 milliliter graduated cylinder. Notice the markings. We've got markings numbered every 5 milliliters with 4 lines in between. So this time every line is a full milliliter. Because it shows every line, we can estimate to the tenths place. Now, if you look closely at the top here, you see this little marking that says TOL plus or minus 0.04 or 0.4. That stands for the tolerance or the precision of this device. When used properly, this graduated cylinder should be accurate to within 0.4 of a milliliter. So the first thing I'll do is I'll fill the graduated cylinder approximately halfway with some water. Get those bubbles out of there. And what I'm going to do is I'm going to try to get as close to eye level as possible and estimate the volume. Let me add a little bit more to make it a little clearer, perhaps. All right. So now I've got my meniscus. As typical with a glass cylinder and water, you see the slightly curved surface. We're going to be going for the bottom of that curved surface. So you look right now, here's 25, 26, 27. We want to turn it basically so we don't see the curve, the whole line around the bottom of 25. If we want to rotate it so that that looks like one solid line at 25, that's more looking directly on at eye level. So if we look at this, the bottom of that curve is actually on or perhaps slightly below the line for 27. So depending on your estimate, you could record the initial volume of this anywhere from 26.8 to 27.2, depending on what it looks like to you. For this particular exercise, I'm going to say the initial volume is 27.0 milliliters. Now we need to get the volume of the metal. The way we're going to do that is we're going to place the metal into that cylinder, and it's going to displace the water, causing the liquid level to rise. The amount that it rises is the volume of the metal itself. So I'm going to take my graduated cylinder. I'm going to carefully slide in my metal cylinder. And I will make my best estimate of my volume. Here's 31, 32, 33. So we're slightly below 34 milliliters. To me, it looks like it's approximately 33.8 milliliters. So that's the measurement I'm going to use for this particular exercise. A little subtraction of this volume minus the volume of just the water gives me the volume of the metal. And I can then use that along with the mass to calculate the density. But like most procedures, we like to do things multiple times so we can check the precision of our process. So we're going to repeat that process again. I'm going to take the metal, dump out the water, dry off the metal, and we're going to repeat it and get another set of measurements. Let's collect the data for trial 2. I have taken my metal, dried it off. I'm going to reweigh it. It should be close to the same mass as it was before, but it may be slightly different. Again, there's always uncertainty in every measurement. But record this mass as the mass for trial 2 for the density of the solid. So I've emptied out the cylinder and put more water in it. This time, my estimate of the volume of the water, it appears to be right around the 32 milliliter mark. If you were seeing this in person, you might be able to estimate a little bit better, but for the purposes of this exercise, we're going to say our initial volume is 32.0 milliliters. So then again, I carefully take my piece of copper, slide it into the cylinder, and I remeasure. The volume has now gone up to approximately 38.5 milliliters. The bottom of the meniscus is approximately halfway between the line for 38 and 39. So my final reading of the solid and liquid for trial 2 is 38.5 milliliters. Once again, calculate the volume of the solid and then calculate the density, and then average the density for your metal.